Hello guys, how are you? I hope all is going fine. And in this video, I'm just going to discuss the notes which is on the reciprocating engine propeller combination, which I have actually promised you in the last video as well. And just to give you the history of what is the topic is about, actually Nicholas Otto in Germany in 1876 actually presented this idea, and it was patented in 1877 in USA. That is a brief history. And the same topic has been taken from what the uh, book which was used in the last video, and also just the continuation of those concept that concept I've actually taken out the same concept. And reciprocating engine propeller combination, which is a 4-stroke internal combustion engine. Okay, that is a century old concept. As per the year is in front of you, the cycle is also called an Otto cycle, and the 4-stroke internal combustion engine is very commonly used engine for the last century or so. So the phases are mainly 4 as per the name, the 4-stroke. So the phases are also 4, and the phases are the intake stroke, the compression stroke, and this is the power or work stroke, and lastly it is the exhaust stroke. So the pictures are in front of you. These 2 are the last 2 phases, and this one are the first 2 one. So intake and spark plug, that is in front of you, that is the intake. That is the spark plug giving the spark or the ignition. That is the cylinder and compressing the air. That is the piston, and obviously with the help of the cylinder is in the shape, and piston is compressing the air, and the connecting rod is connected to the piston, and also crank is, which is known as the crankshaft, is also connected to the connecting rod. So it has been actually rotating like this. Intake stroke, intake valve opens, thus admitting charge of fuel and air. This valve open admits air and fuel, and exhaust valve closed for most of the stroke. So this is the exhaust valve which is closed for most of the stroke, especially in this first phase of the 4-stroke internal combustion engine. And when we talk about the second phase, which is the compression stroke, both valves close. Both valves are closed, which is the intake valve and the exhaust valve are both closed. You can also these valves are also closed, and in here it is actually open. So there can actually we can have this is intake movement through the cylinder, and also this piston is compressing the air. Now in the compression stroke, both valves close. Fuel is present, and the air normally is being actually is from the intake, or normally the fuel and the air both comes from the intake valve, and fuel air mixture is compressed by rising piston. This is now the compression state, because in this fuel and air are present, which are now being compressed. The mixture is being compressed. Sparks ignites and ignites mixture near end of stroke. Obviously when this whole stroke is completed, because of this compression there will be a spark ignition at the end of the stroke. Okay, so in the third phase, that is the intake manifold is in front of you, and also the exhaust manifold is in front of you. And now it is moving downward. Here it was moving upward, here it is moving downward, upward, and yet again then it is downward. In the third stroke, or the power or work stroke, fuel air mixture burns. Now the mixture burns, increasing temperature and pressure expansion. Now here what, because of the compression, ignition takes place, or the spark takes place, and now the sparks turns this mixture into a burning phase, and increasing the temperature obviously of the mixture, and pressure expansion of the combustion gases drives piston. And because of the pressure expansion, when there is increase in the temperature, when there is a burning that normally takes place in the fuel air mixture, the burnings takes place, there would be a rise in the temperature, and the pressure expansion of combustion gases drives piston down. Okay, so the obviously because of the expansion of the gases, the combustion gases, normally because of the ignition, and ignition turns the mixture into a burning phase, increasing temperature, and because of that it drives the piston or piston. It is the piston, and both valves close, exhaust valve opens near end of stroke. Obviously both valves needs to be closed, but the exhaust valve manifold will open just at the end of the stroke, because normally one stroke is connected to the other, the second is connected to the third, and third is connected to the fourth. Nothing is actually apart or actually working in a loop. So you need to understand that all the four strokes are connected one another with the help of the valves. One in one phase, in the first stroke, which is the intake stroke, the intake is open, the exhaust will going to be, and the exhaust valve closed for most of the exhaust valve is normally closed for most of the stroke, that is mentioned over here as well. And in the second stroke, which is the compression stroke, and this because of the sparks which ignites a mixture, which is normally the end of the, it is normally both valves are closed. In this compression state, both valves are closed, and it will be closed for all in the compression phase. You don't need to worry about. But in the power or work stroke, what happens, both valves are closed, but obviously the exhaust valve will be open at the end of the stroke. And in the last stroke, which is the exhaust stroke, exhaust valve opens as it was going to open at the end of the third stroke. Exhaust products are displaced from cylinder. Okay, now it is being moving upward. The exhaust products are displaced from cylinder, intake, and valve opens near the end of stroke. So that valve, cylinder exhaust valve just open at the end of the stroke. This is how you're going to manage the four-stroke engine combustion. That is how it is being understood, and it's very commonly, and it is a very old concept, just to keep in mind. It's not a new one, but just to give you an idea that how a reciprocating engine propeller work. Propeller is the same as propeller works as the same as it is normally, it is in the aircraft. So I'm going to discuss what is the function of the propeller, and also we're going to discuss some other details. The business end of reciprocating engine is the rotating crankshaft. Obviously we have learned the crankshaft, that is this one. This is the business end of the reciprocating engine propeller. Okay, and reciprocating engine is is the rotating crankshaft. This obviously this is the business end of the reciprocating engine, as the rotating crankshaft. This is the means by which the engine's power is transmitted to the outside world. This is how the engine's power is transmitted to the outside world. Okay, with the help of this crankshaft. A wheel axle in the case of an automobile, or propeller in case of an airplane. So what is a wheel axle in the case of an automobile, or propeller in case of an airplane? Obviously I have discussed why it is crankshaft is a crank or propeller. A wheel axle, which is works at the same in the automobile, the propeller works the same as the airplane. Okay, so what characteristics on which power depend? That is the question. First is the sheer size of the engine, which is known as displacement in technical terms, and on its travel from the top of a stroke, obviously top dead center, to the bottom of the stroke, which is the bottom dead center, the piston sweeps out a given volume called displacement of the cylinder. Okay, that is how when the stroke comes from the top to the bottom, and the piston will going to sweep out the given volume, which is known as the displacement of the cylinder. So displacement, which is known as total displacement, is the displacement of the cylinder into the number of cylinders, and higher the total displacement, higher the which is the power output because of the engine. Okay, and that is how it's been discussed. So number of times there is a movement, there's an up and time movements, obviously that would influence the power output because of the engine. Normally the stroke is in the engine, in the 4-stroke cylindrical combustion engine. So normally when there is an up and down movement from top to bottom by in the form of strokes, so that will give us the displacement, but also influence the pressure, the power as well. And when there is more stroke and more movements, or that is the power stroke per minute, there would be or that would be more output because of the engine. More power stroke per minute, that will give us the more you can say output per the engine. And when there would be more strokes or the power strokes, there would be more revolutions per minute, RPM, and then there would be more RPM, there would be more power eventually. So these are connected all together. You can name the strokes per minute to the revolutions per minute or RPM, so that will give us the more power. So eventually we can say that when we increase the pressure in the cylinder, there will be also the power output because of the engine. That the relationship can also be understandable. So strokes will give rise to more power, more RPM eventually gives to more power, and also with more pressure there will be more power as well. An average pressure, which is indicative of pressure level in a cylinder, is defined as mean effective pressure PE. Okay, and an average pressure, which is indicative of pressure level in a cylinder, is defined as mean effective pressure PE, which is P is equal to shaft brake power, which is P, and P is directly proportional to displacement. It is also directly proportional to P of E, and which is obviously the power because of the engine. Displacement multiplied by power into engine into RPM is directly proportional to the P, which is the shaft brake power P. Okay, so shaft brake power means crankshaft brake power. So obviously when the crank moves, there would be more strokes, and there would be more strokes, there would be more displacement, and maybe there will be total displacement. Obviously the more strokes, there will be more strokes, the piston will move, and also it will move, sweeps out a given volume, which normally is called the displacement. When there is a displacement, there is more power, more strokes, more RPM. So these all together will actually directly proportional to the shaft brake power. And PE is normally as known as the mean effective pressure. PE, it is not the power because of the engine, it is the mean effective pressure PE. So mean effective pressure PE multiplied by displacement into RPM is directly proportional to the shaft brake power. It is the mathematical expression that we just have to keep in mind. So it is PE, which is the pressure because of the engine, RPM, and displacement, which is directly proportional to P, which is the a shaft brake power. So this is how you're going to explain this small relationship, and obviously it is dependent upon the characteristics that we have discussed earlier. First of all, what was the shear pressure, the shear size of the engine, and when there is a larger the size of the engine, there will be the displacement would be higher. Okay, so obviously when the displacement will be higher, when the stroke will move, or when there is a movement up and down, there will be a more actually you can say piston sweeps out more volume. And when there were more volume is actually stepped out, we can say that it normally depends upon the size of the engine as well. So all the factors, D, which is also the mean effective pressure PE, and all dependent on the RPM as well. So RPM will leads to the pressure of the cylinder, and normally we going to say that that pressure is the mean effective pressure PE. Okay, that power, pressure, Stokes revolutions are all our four are actually correlated. So that is what we have actually taken as this concept. Specific fuel consumption is a technical figure of merit for an engine which reflects how efficiently the engine is running fuel and converting to power. That is normally the specific fuel combustion. That is the technical definition for the same concept. How the efficient is, you can say, the engine is because how efficiently the engine is converting fuel to power. For an internal combustion reciprocating engine, which we are discussing, specific fuel combustion C is defined as this. C is weight of fuel consumed for given time increment divided by power output into time increment. That is how you're going to explain it. So weight will be described in pounds lb, and power output would be into ft feet into lb per second into time increment, which is also in second. Okay, so this is how it has been explained in standard international units. That is the standard international unit, but commonly C or this specific fuel conversion is not being represented in standard international units. It is represented in what specific fuel conversion, which is CFE, is represented. Normally we are going to actually, when we're going to convert and stand SI, it is Newton into Newton per second. Okay, so when there is the specific fuel consumption, normally it has been represented as LBS divided by horsepower into H. Okay, this is normally the way of actually expressing the specific fuel consumption. That is not the correct way or the standard way, but it is normally being mentioned in most of the books. So you just have to keep that in mind, and you can follow that units just in case if you want to actually convert some numerical based question into this unit for the specific fuel consumption. But the formula is front of you, weight divided by the power output into time increment. That is how you're going to explain. So this is what we have learned. We have learned the relationship, we have learned the small technical term, we have learned about the characteristics, and we have learned about the wheel axle in case of an automobile works are the same as a propeller in case of an airplane. So that is more sort of the same line definition. So the wheel axle in the case of an automobile or propeller in case of an airplane. So you need to explain. And we have also discussed about the four-stroke combustion or the four-stroke internal combustion engine, which is from, if you talk about from motorbike to motor cars, and from motor cars to aircraft to airplanes. Normally, if you are talking about the basic structure, the four-stroke internal combustion engine is more or less the same, and it's been working in different machineries from even at the ship level as well. And you can say that even when we're talking about the ships, when we're talking about the airplanes, you're talking about the small machinery. In every machinery whatsoever, this four-stroke engine or the internal combustion engine is present. So it is one of the prime or the one of the most important concept that is normally used from household to industry level, and from industry level to high-tech level, and eventually for the corporate sector as well. Normally this concept is normally present, but for the educational purpose we have taken this concept from the same book which was actually being dealt in the last video. So I have discussed about the history, I have talked about the concept. It is under the same reciprocating engine propeller combination. Okay, and it is under the same concept, and we have talked about this. And in the coming videos we're going to later discuss how we're going to have the velocity or the variations in this concept, and we can get further the power variation, the velocity variations, and we can have the further explanation of the concept as well. So I believe this whole four-stroke internal combustion engine concept is being explained to you in a very short, precise video. And if you have any questions regarding it, you can ask straight away, and we can actually just join together to actually complete any, actually you can say, concepts. So let's see what we can actually have from this further from our approach. And till then, if you are interested, you can actually like, subscribe and comment, and else you can visit our services and actually product video as well. And if you are interested, you can ask for any further work or for the project approval. So let's see how it can be done, how it can be actually explained further. But we are in a path of explaining the engineering concepts, and more or so to the technical nature and conceptual nature, and obviously of the logical nature. So that is how we're going to attempt and going to actually go further beyond this, even beyond this channel. We'll able to actually provide you further videos even after some time. We're going to actually just create a separate channel so that you can have some extra bit of the information just in theoretical form, in paper form, and you can have this discussion to be continued for further videos and for further channels as well. So you don't need to worry about. We will be stay in touch, and I'll hope to see you in some short time. And meanwhile, I'll just let you know that the same concept has been actually in the course book of IIT Kanpur, and obviously YouTube help us to actually utilize, and the internet help us to actually utilize the free stuff. And we are very thankful for actually IIT, Indian Institutes of Technologies, Kanpur, or any other institute providing us the stuff in terms of videos, in terms of lectures, and also in terms of resource materials. So we are very grateful and thankful for providing, and we are just sharing and hopefully explaining to the maximum and up to the merit what are the engineering requirements and what are the engineering fundamentals that is necessary to be actually shared, that necessary to be communicated in a manner that is applicable and that is also understood by the engineering faculty and also by the engineering students, and in general by the public as well. So I hope the approach would be appreciated, and would in the form of the comment, like, share, or even in the form of the subscription. Do visit, do share. I will be grateful. Thank you very much. Take care and have a nice day.